The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, and welcome to today's webinar on insulation resistance testing. Good morning to all our viewers joining us within the US, and good afternoon and good evening to all those joining us from other countries. Before we begin our webinar, just a few notes. First of all, we have a Q&A utility where you are welcome to ask us any questions about the material being presented. And also joining us today is Pete Stevens, one of our sales managers, and he'll be assisting us in answering any questions on the chat line. And our host, as usual, is Jim Kennedy, who will be providing technical support, and any questions related to audio or video or any other technical issues with the webinar, please address them to Jim Kennedy via the chat line. And if you would like a copy of this of today's presentation, feel free to email Jim at jimk@asresearch.com. Okay, I think we have enough people to go ahead and start going over today's material. So just a quick recap of what we covered during our last webinar, which was on electrical safety testing circuit theory. And basically what we covered in that webinar was we reviewed some of the common electrical safety tests. We also went over what is exactly tested during each of those electrical safety tests, and then we looked at what the circuits, how the circuits look like for each of those tests, and we also looked at some of associated research patented features that are available in most of our Hipot testers, such as arc detection and smart GFI. So once again, today's webinar is on insulation resistance testing, and it's one of the webinars in our 2014 series where we are focusing on just one test type. In the past, we've dedicated webinars on individual tests such as Hipot, ground bond, ground continuity, and this one is on insulation resistance testing. Here's an outline of what we will be covering in our webinar today, and we're going to start by understanding what the insulation resistance test is. And even before that, we're going to try and understand what insulation is and why is it important to test the insulation of your product. Then we're going to go over a few differences between the insulation resistance test and the Hipot test. The reason being that the insulation resistance test is very similar to the DC Hipot, which we have covered in the past in quite a bit of detail. So if any of you have missed any of our previous webinars, you can, we have recorded all our webinars and they're available to view on our website. This webinar will be available as well in a few days. So, and then next we're gonna cover some of the test considerations for the insulation resistance test, and then we're gonna go over a few videos of an actual insulation resistance test being performed, and then we're gonna leave the forum open for any questions that you may have. Okay. So before we start studying or learning what insulation resistance test is, it is very important to understand what do we mean by insulation. Well, insulation is used in all the electrical equipment to support and separate electrical conductors. It is what provides separation or a protection barrier, preventing excessive fault currents to flow on the chassis of the product. Therefore, it is used to separate conductors within a product, and it also provides a protection barrier. But what happens is that over time, the insulation of a product can be damaged, and it may fail to provide protection and separation. Some of the common factors that contribute to the failure of insulation of an electrical product are excessive heat or cold. We know our insulation resistance, our products are used in many different environments or conditions, so high and low temperature, moisture is a big factor, dirt, corrosive vapors, oil, vibration, aging itself, and just poor quality of insulation used in the product. All these factors may lead to an insulation being damaged or not being strong enough over time. Therefore, it is strongly recommended that the insulation of all electrical products be tested and checked on a regular basis, and hence the need for insulation resistance test arises. So insulation resistance test is a test that will test the insulation, give us a value in in ohms, a resistance value, which will tell us how good our insulation is, and then the manufacturer can predict if the insulation needs to be repaired or replaced, or how basically you can predict when the insulation is due to be replaced. Okay, here's a quick example of insulation. I know we've been talking about insulation. Here's a quick example showing us, now this is a simple example of an insulation on a bunch of different wires, and you can see over time the insulation has deteriorated, and you can see exposed conductors. Similarly, within an electrical product, inside an electrical product, the insulation can go bad over time. So that's where the insulation resistance test comes in. Next, we're gonna do a quick poll. We're gonna pause here for a moment, and Jim is gonna start a quick poll, and you guys are free to. We request that you participate in this poll. Gives us some good information so that we can improve upon some of our material.
Hi, Syed. I just wanted to share the results of the poll real quick. We had basically 40% say that they do test it per their standard. Another 36 say that they test it due because of their company requires it, and then about 24% do not currently perform. Thank you.
All right, thanks a lot, Jim, for sharing the results with us. Based on the results, it looks like about 70% of you guys do perform an insulation resistance test. It may be required by your company or by your standard. So that's great. You guys will get some good information on the insulation resistance test today. So we're going to continue with our material now, and thanks for participating in the poll. So here's a quick review of some of the common electrical safety tests that we have covered in quite a bit of detail in some of our past webinars in 2014. And starting with the ground continuity and ground bond test, of course, these two tests are testing the ground circuit, of our products, of class 1 products, products that have a ground pin or ground circuit. Then we covered the dielectric withstand test, the Hipot test, which also stresses the insulation, but it looks for leakage current. And the result of a dielectric withstand test, especially the DC dielectric withstand test, is very similar to the insulation resistance test, but the result is slightly different. And of course, we did cover insulation resistance tests in the past, not in that much detail, but we will be going over this today. And also we touched a little bit on the touch current test. Next few webinars that we're going to be presenting are actually focused on just touch current or line leakage testing, so do join us for those. So the reason I wanted to bring up or review real quick some of these tests that we've covered is because for example, the dielectric withstand test also stresses the insulation in the same fashion as the insulation resistance test. But again, this test, the Hipot test, is looking for leakage current or breakdown of the insulation. It gives us those numbers for leakage current and tells us if the insulation will break down as a result of the applied voltage. Whereas the insulation resistance test will give us a value in resistance. It'll actually give us what's the mega ohm or the ohm value of the resistance of our product. So what is the insulation resistance test? Well, the insulation resistance test is used to provide manufacturers with a quantifiable value for the resistance of their product's insulation. This test is usually performed on a product after it is manufactured, installed, or repaired. It could also be based on company requirements. It may also be performed on the production floor. It is it is also commonly performed as a routine maintenance test on products such as motors, generators, and it helps to predict if a product is due, if a product's insulation is due to fail. So it gives us some very good information. So basically what the insulation resistance test does is that it applies a DC voltage across the insulation of a product and measures the corresponding leakage current, which is then used to calculate the resistance of the insulation. The insulation for short, IR for short, test measures the resistance offered by an insulating material to the flow of current resulting from an applied DC potential. And the DC potential here is applied normally between the current carrying conductors and ground. Now this is where this test is very similar to the DC Hipot test, because during a DC Hipot test the potential, which is higher than what is used for insulation resistance test, is also applied between by shorting line in neutral if it's a three-prong product, and it's applied between the mains current carrying conductors and ground. And then again, the resulting leakage is used to calculate the resistance using the Ohm's law. So basically, this test is, it relies upon by the simple use of Ohm's law. It looks at the leakage current, which flows on the insulation due to the applied potential, and then it calculates the resulting leakage based on that current value. Here is what the circuit for the insulation resistance test looks like, and if you notice, this is very similar to the Hipot test, or more commonly the dielectric, the DC dielectric withstand test. So That's why the two tests are very similar, but the result of an insulation resistance test is displayed as a resistance value in ohms or mega ohms. In this picture, you can see that the high voltage is applied by shorting the mains conductors of our device under test, that is on the right side. And very similar to the Hipot test, the resulting leakage is measured through a return cable that's connected either on the chassis of the product or the ground connection of the product. And then that leakage current value is used to calculate the resistance that that was offered by the product's insulation. Next, we're going to look at a quick video that I've put together to show how an insulation resistance test can be performed using one of Associated Research testers. The tester, basically it's the test equipment that we're going to use in this video that I've shown in this video is showing the Omnia 2 series, which is a complete electrical safety compliance analyzer. And we'll just play the video for you guys. So what we're testing here is a simple fan that's used at soldering stations, and we're connected through a bunch of different cables. As you can see, the high voltage is that's where the high voltage is going to be output. We're going to set our test at 1,000 volts with a high limit. We're not worried about the high limit here, but what's important in an insulation resistance test is the low limit, because we want our insulation, the insulation of our product, to be at least some value, which may be called out by the standard or by the manufacturer of the product. One more thing to notice here in this test is that we are running this test for 60 seconds. So this test is programmed to be run at 60 seconds, and I'll go over why we ran this test for 60 seconds. Where did the requirement come from? So basically the product that we're testing here was plugged into an adapter box which is connected to the Omnia, and the adapter box is where the high voltage is being applied by shorting the line and neutral of this product, and this black lead that's connected to one of the screws or the chassis of the product is providing the return path for the circuit to complete and give us a measurement, give us a reading. And as you can see, the display result of the insulation resistance test is being displayed in mega ohms here in this case. As you can see, the time on the right, bottom right of the screen of the Omnia. So at the end of the 60-second cycle, I've added a small ramp down time because we're applying a DC potential, and as we know, all devices are somewhat capacitive, so we want to ensure it's fully discharged at the end of the test. So at the end of the test, when we look at the results, we see that the display that says 33,289 mega ohms. Now this is a pretty good value, resistance value, for the insulation of a product that's pretty small in size. And so basically what we saw here was we gave the test enough time to get a stable reading, and that's one of the considerations that we have to keep in mind when performing an insulation resistance test. So we're going to continue with our presentation here. So basically, the insulation resistance test, most insulation resistance testers have a variable output voltage. The test voltage is usually specified at 500 volts or 1,000 volts by the safety standards. Now this requirement may change if the insulation resistance test is an internal company requirement. The voltage may change here, but going by the standards, this is what is normally called out for, is 500 volts to 1000 volts. And the minimum acceptable resistance value is also should be specified by the safety standard that you're trying to comply with. So it is very important to read the safety standard that you are trying to comply with, or the requirements that you are trying to meet when performing an insulation resistance test, or for that matter any electrical safety tests. Once again, unlike a Hipot test where we set high and low current limit or thresholds, for the insulation resistance test, what is more important is the low limit for the resistance, because once again we want the result or the resistance of our product's insulation to be at least some value that may be called out by an internal company requirement or the safety standard. For example, some safety standards call out for an insulation resistance value to be at least 1 megaohm or 2 megaohm. So based on that, we can set our low limit for the resistance for this test, and that will also ensure that we're not getting any false failures or passes in our test. So we basically want our product's resistance to be above a certain value, and that is why the low limit is very important here. Okay. Now, acceptable insulation resistance readings can vary again, based on the safety standard. Therefore, it is very important to read the standard that you're trying to comply with. That will give you all the information for setting the test parameters. Now, although the insulation resistance test is related to the DC Hipot test, the IR test provides a little more information about the device under test, which can be useful in certain applications. Further, the insulation resistance test is sometimes called out by the safety agencies to be performed subsequent to the Hipot test. And the reason for that is we want to make sure that after performing the really high voltage Hipot test, AC or DC, the insulation of our product is still intact and it was not damaged. So it is always a good practice to include an insulation resistance test step in your test sequence if you are running a Hipot test. It'll just give you more comfort in knowing that the insulation of your product was not damaged. Now, the insulation resistance test is always performed using a DC potential. This is due to, as we know, the real and the reactive current components produced as a result of the product's dielectric, or in this case, the dielectric is the insulation. When we apply a DC voltage to the device under test, it negates the reactive, or sometimes called the imaginary current components that are caused by the product's capacitance. We know that all products are somewhat capacitive in nature, or most products are somewhat capacitive in nature, and when a potential is applied to it, if especially an AC potential is applied to it, there will be a real and a reactive component of current. The real due to the resistance, and the reactive due to the capacitance of the product. Applying a DC, so basically applying a DC voltage negates the reactive or the imaginary current component, which is caused by the product's capacitance, and therefore it allows the insulation resistance test to perform a true real current measurement. Now, if this was not the case, the insulation resistance tester would produce erroneous resistance measurements with consistently lower values. So it is very important to perform this test, the insulation resistance test, in you are using a DC potential. A few other things to note during an insulation resistance test are sometimes the insulation resistance test is used to find what we call the polarization index of our product. What is polarization index? Well, polarization is the ability for materials, dipoles, which basically are equal and opposite charges separated by some distance, to line up in the presence of an electric field. Now, a lot of people who perform the insulation resistance test may not have heard of this term, the polarization index, but as these dipoles align themselves, absorption current is created, which decreases over time. Now, initially, this absorption current is high, but as fewer and fewer dipoles are left to align themselves with the applied field, the current drops. Therefore, an insulation resistance measurement taken after 1 second would yield or could yield a lower resistance than an insulation resistance measurement taken at 60 seconds. Now, going back to the video that we just saw, the reason I ran the test for 60 seconds was because I want to give my test device enough time to get a stable reading, stable measurement. So that's the reason why I had programmed my test for 60 seconds. In fact, I mean, sometimes the insulation resistance test, some manufacturers like to perform this test for 10 minutes. They want to give their test equipment a very long time to get a stable reading. And in order to find the polarization index of a product, what the 10-minute test result is divided by the 1-minute test result. This resulting ratio of the test results is what is known as the polarization index. Now, some manufacturers like to perform multiple polarization index tests over the life of a product in order to keep the quality of their product's insulation in check. Therefore, this also tells us the importance of keeping the insulation of our equipment, of our products in check, and the insulation resistance test provides us with a very good solution for keeping a check on our product's insulation, which can go bad over time. Now, once again, going back to the point where we know that most products are in some way capacitive in nature, there are a few considerations that need to be taken into account when performing an insulation resistance test. So basically, as with a DC Hipot test, the insulation resistance test also applies a DC voltage across the dielectric or the insulation of a product. Now, since most products are capacitive, in some way are capacitive in nature, the test operator should be aware of a few things, which includes the test time. It is very important to allow the test to run for a period of time before recording any measurements. Again, going back to my point in setting a 60-second time for our test in the video that we just saw. And the reason we want to give our tester enough test time, and I'm emphasizing on this fact again because this is very important in an insulation resistance test. The timings and the accuracy play a big role in the results of the test itself. So we need to allow the tester enough time because the charging currents this is due to the charging currents that that are necessary to charge the capacitance of the product. If this current isn't allowed to settle over time, the test could again produce erroneous results, and that's why most standards call out for a test time of at least 60 seconds in order to record an accurate measurement. Okay. Once again, for anyone who has any questions on the material being presented or any technical assistance required, please feel free to use our chat line, and also you can email us with any questions that you may have. Next, I'm going to show you another quick video, and the reason I wanted to include this video is because I want to show what a smaller a smaller test time when we program our insulation resistance tester with a shorter duration of test time, what kind of results can we see. And we're basically going to show the same equipment, same product that we saw in our previous video, but this time I've programmed the test to run only for 5 seconds compared to the 60-second time that I programmed for the previous tests. So just bear with me while I pull up this video. Okay, so once again, as you can see from the screen, everything else stayed the same, but the dwell time changed to 5 seconds instead of 60. All the connections are still the same. The device is plugged into the adapter box. The return lead completing the circuit is connected, and I'll go ahead and initiate the test. And what we're seeing here is the voltage has ramped up to the 1000 volts, but the test time is only allowed to run for 5 seconds. So at the end of our test, after the ramp down, as you can see the voltage ramping down right now, we're going to go look at our test results. And what we see here is a lower value. If I remember correctly, in the test that the video that we ran before this, for a 60-second insulation resistance test, the resistance value came out to be something around 35,000 mega ohms. Here it was in the 23,000s. Therefore, this tells us that we did not give our tester enough time to produce a stable reading, and this may give us false readings of our insulation, and then the whole purpose of the insulation resistance test is to get a good feel or idea of how good the insulation of our product is. Few other considerations when performing the insulation resistance tests are, for example, the accuracy of the test. When performing an insulation resistance test, accuracy plays a big part. And for this reason, it is very important to keep the test conditions during the insulation resistance test as stable as possible each time the test is performed. Variables like temperature, humidity, cleanliness of the device and the test are all factors that can contribute to the insulation resistance measurements, and they can alter an insulation resistance test measurement and produce erroneous results. If the temperature during the test cannot be controlled, there are ways the insulation resistance measurement must be corrected for a temperature of around 40 degrees centigrade. And a general rule of thumb states that for every 10-degree increase in temperature, we divide the insulation resistance reading by 2. Likewise, for every 10-degree decrease in temperature, we multiply the IR, the insulation resistance reading, by 2. Again, this is This is right out of the standards, and if you are performing your insulation resistance test in an environment where temperature is not stable, a good rule of thumb is to basically account for the temperature increase or decrease. And now, when performing an insulation resistance test, it is also very important that, just like for any other electrical safety test, it is very important that the personnel performing these tests should be well trained. The reason being, these tests, this is a high voltage test and it produces some leakage current. Therefore, whoever the operator is, he or she needs to be well trained in using the tester itself and knowledgeable about the test. What are the possibilities of the test? What kind of results are we looking at? What is being really tested in this test, and what are the possible safety issues while performing this test? Technicians will be exposed to potentially lethal voltages. In order to avoid injuries and fatalities, every manufacturer that incorporates safety testing into the production process should make sure that the test operators are fully aware of the risks that are inherent to the job. And providing operators with proper education about the basics of electricity and safety testing will help a long way in avoiding injuries and costly lawsuits. So some of the we're now going to go over the quick summary for what we just covered, but before that, let's quickly go over some of the common questions that come up regarding the insulation resistance test. So basically, starting with what this test does, just to summarize, basically the insulation resistance test measures the resistance offered by an insulating material to the flow of current resulting from an applied DC potential. The DC potential is normally applied between the current carrying conductors and ground. The test is usually done on a product after it is manufactured, installed, or repaired, and it is also commonly performed as a routine maintenance test on products such as motors or generators, and can help to predict if the insulation is due to fail. Next, a common question regarding the insulation resistance test is, what is the difference between a mega ohm meter and an insulation resistance tester? Well, essentially they are both the same. A mega ohm meter refers to an instrument whose meter is usually scaled to read in the mega ohm value, or millions of ohms. That's basically the big difference here, is that the meter of a mega ohm meter is scaled or set to read in the mega ohms, whereas in an insulation resistance tester, it refers to an instrument that measures the resistance of a product's insulation system. The other big question that comes to mind when dealing with the insulation resistance test is, what is the difference between a Hipot test and an insulation resistance test? Now, I know we did cover this somewhat during our material today, but just to go over it once again, because this is a very common question. The insulation resistance test is a qualitative test that gives an indication of the relative quality of a product's insulation system. This is an ideal test for actually studying, measuring, and recording long-term stability of insulating materials over time. Whereas the Hipot test, or the DC Hipot test, which is more similar to the insulation resistance test, is commonly specified as a production line test for electrical products. The Hipot applies an excessive voltage between the current carrying and non-current carrying parts of the is to stress the insulation system and verify its integrity by measuring the leakage current that flows as a result of the applied potential. The Hipot test is a more stringent test and it is most often a go no-go test, whereas the insulation resistance test is done at a lower potential, for example 500 or 1000 volts. Now another common question for when dealing with the insulation resistance test is what is considered to be an acceptable insulation resistance reading. Well, this is where I would definitely, if I was a manufacturer of a product, I would definitely find out which standard does my product fall under, and the first thing I would do is to get a copy of that standard and read through it in a lot of detail, paying close attention to the details, because that's your best resource for finding out test parameters and other test settings that may be required for your product. We did cover Polarization Index, so therefore the only thing that I want to go back to is that it is very important to allow the insulation resistance tester to enough time because the insulation, as we saw, the insulation resistance measurement taken after 5 seconds would yielded a lower resistance than an IR measurement taken at 60 seconds. And we saw that it was very evident from the two videos that we saw. The other common question that arises when dealing with insulation resistance test is called what is trending, the term trending. Now I know a lot of you may not have heard this term because it's not very common, but it does come up from time to time, and that's the reason why I want to go over it real quick. Trending is a term that is used to describe the process of taking repeated test measurements over time. So basically, it's a very simple term if you go by the definition. It is used to describe the process of taking repeated test measurements over time. Now, in this case of an insulation resistance testing, trending the test results can provide useful information about a product's integrity, and it can yield clues as to when its insulation should be repaired or replaced. Here's a picture at the bottom of a transformer being tested for insulation resistance, and the test equipment or the test instrument shown in this picture is the Hipot Ultra series of testers, which is basically a AC/DC Hipot tester, insulation resistance, and continuity tester. So it's one of our very hot selling products, very reliable, and is capable of going up to 50 meg of insulation resistance. And similarly, Associated Research has come up with many different models, test instruments that are capable of performing insulation resistance test at very high resistance values and being able to measure high resistance values. For example, the Omnia that we saw, the Omnia 2 series that we saw in the two videos, that's a complete electrical safety analyzer. But basically it's a 7-in-1 tester. It's capable of performing AC, DC, Hipot, ground continuity, ground bond, insulation resistance, functional run, and line leakage. And on top of that, it can be configured in different models to come available with the internal AC 500 VA power source, and also it could also be configured to as a 500 VA Hipot tester, which is capable of measuring up to 100 milliamps of leakage current. So again, like other electrical safety tests, the parameters vary upon the standard. So it is very, very important. I'm going to emphasize on reading the standard because you are in some way trying to comply with a safety standard, because every product, electrical product, falls under a certain category, and there is a standard available, a safety standard available, whether it be UL, EN, IEC, or whatever. But the standard is what should be your guide when figuring out which electrical safety tests are required for your product and what are the test parameters and settings. For example, EN 60204-1, which is the standard European standard for safety of machinery, specifies a 500-volt DC test between the power circuits and conductors and the protective bonding circuit, basically the ground. And it's also calling out for a resistance value. So basically, here is all we need to basically set up or program a insulation resistance test. It's giving us the voltage and the minimum resistance required. So basically what it's saying here is that the resistance of your product should be at least 1 mega ohms, not less than 1 mega ohm. So based on this, we can set our test trip threshold settings. Similarly, Associated Research has other products, other models that are smaller, 2-in-1 tester or 3-in-1 tester, such as the Hipot 3, Hipot Ultra 3. So I would definitely recommend, if you are in search of an insulation resistance tester, do visit our website at www.asresearch.com, and feel free to look around. We have a very good product selection wizard that you can use, and if you have any particular or specific questions regarding a particular tester, please feel free to email us, and we will definitely be try and help you out as much as we can in finding you the right tester for your testing. With this, I would like to leave some time open for any questions that you may have, and so please feel free to forward any questions while we have some time left.
Syed, we have a couple of really good questions.
Sure.
That I wanted to throw past you.
Mm-hmm.
First one is actually, this is a really important feature on a lot of our testers, but someone had a question in reference to the charge low feature, both in IR and then of course it's available in Hipot as well. But it would be good to kind of review that feature and the value of it.
Sure. We can definitely go over that. So basically, the charge low feature available on some of our electrical safety testers is, and this is, first of all, this is a patented feature of the of Associated Research, and what it basically does is when performing a test, it confirms that the proper connections are made, meaning that if you are performing a test and your test leads are somehow you forgot to connect your test leads, using the charge low feature will give us an indication that something is not right about about the test setup, and something is maybe disconnected or loose, or something's not right. So a very important feature to use during a DC high potential DC test or an insulation resistance test. Once again, we have some time open for any questions, so feel free to keep forwarding questions via our chat line.
Got one more for you here, Syed. It's actually a pretty good one. For back to the polarization index, when you're doing a short test like this, as well as a 60-second test, and then afterwards you would do a PI calculation, do you get a meaningful result, or does that short time, in other words, that short test, skew the result in some way?
No, that's first of all, thanks for forwarding this question. It is a very important question. Well, so basically, when measuring the polarization index, you know how we divide the 10-minute test by the 1-minute test. So the resulting ratio of the tests that we see is, that's the polarization index, and it does not skew the results. It will actually give you a stable reading. And as we saw from our video, our test was, the first test was run or programmed to run at or for 60 seconds, and we did get a stable reading. If I was to repeatedly run that test for 60 seconds, I will get, if not the exact same value, very close value to what I got the first time. Therefore, for a 10-minute test, the resistance value should come out to be also very close to what we saw in the 60-second test, because it's all about giving your tester enough time to come up with a stable reading, and the reason being the capacitive element of your product. You want to make sure you're giving it enough time to fully charge the capacitance of your device. And to answer the question, yes, doing for calculating the polarization index, dividing the 10-minute test by the 1-minute test will give you real results.
Okay, Syed, one last question. It's back to
Sure.
Polarization index. What readings would you normally see? What are the typical values of the index? And are there any standards requirements out there that call out PI as a requirement?
Well, as far as the polarization index is concerned, I have not seen any as such requirements in the standards. Maybe and I'm not going to say that there aren't any. I may just not have come across them yet, but from what I know, usually the polarization index is an internal company requirement, because the manufacturer wants to run this take this extra step and go beyond the conventional IR testing and perform tests to find the polarization index of their products to keep the insulation of their product under check.
Right now, I think that's it, Syed.
Okay. Well, if there are no other questions, I would like to thank you all for joining us and being with us and being patient. And I hope this webinar will be useful for you guys, and you did gain something out of it in terms of insulation resistance testing. As you all know, this presentation it will be available. This webinar was recorded, and it will be available on our website in a day or two. But if you do need this presentation urgently, please feel free to email Jim Kennedy, and we will send you a copy right away. And if you have any other questions, you are also free to email us with any questions, and they will be forwarded or directed to me if they are related to the technical material that we covered. Make sure to visit our website at asresearch.com for any other information regarding our products. We have multiple webinars that we've recorded, archived, so you're free to use these resources. We have a lot of white papers, and our next, make sure to join us on September 24th, Wednesday, September 24th at 10 a.m. Central Standard Time, for our next webinar, which is on touch current testing 101. So basically, we've split the touch current in 2 different webinars, 101, 102. We're going to go in a lot of detail regarding line leakage testing during that webinar. Also, don't forget to follow us for some electrical safety news, product updates, job opportunities, and miscellaneous other information by following us on Twitter at IR and Hipot. Also follow us on LinkedIn. In the end, I would like to provide some more contact information for those who missed out on this. Jim's email. Jim is our host as usual, and his email is jimk@asresearch.com. Feel free to email him with any questions, and if they are for me, they will be forwarded to me. And once again, thank you very much for joining us, and thank you, Jim and Pete, for providing all the support during this webinar. This is Syed Abidi, your presenter, signing off. Have a good day.